Hello Factorians, and welcome to this little video introduction of my smart network train system. Basically, I've been looking for a long time to figure out if there was a way to do a proper supply and demand kind of design for train stations, and there isn't quite that. Or you'd have to use a mode like the logical train network, but I'm not a big fan of mods in general, so what I wanted to get to is something that is sort of similar to what I've only just recently been introduced to reading posts on Reddit as the vanilla train network, which is a system where you've got a supplier sort of train station that is going to have a train into it, and the train's going to wait for the network to say there's a station that requires ore, just go there and dispatch. So I've kind of reused that principle of supply and demand, but in a slightly different way. So if we think of suppliers in the real world, right, these guys are going to produce goods. They produce goods, the goods go to a warehouse, and the warehouse dispatch the goods. So basically I've kind of used that. So in this mini-map that I've created here, there isn't exactly a supplier to showcase, because I suppose there is loads of ways to do the supplier go to the warehouse kind of thing, but I've done basically the blueprints for the sort of warehouse or yeah, dispatch. Actually, I've called the train station dispatcher. That, to be honest, train station, a carrier train station, because obviously when you go to the warehouse, then the warehouse just drops the goods to a carrier, and the carrier goes to people's homes or offices or whatever, and does that to the consumer, well, which here I've called requester. And the thing I've introduced is that idea of the standby station, which is basically at the warehouse. If you've got loads of goods, but you don't necessarily, and you're waiting for goods to come into the warehouse before you can dispatch them, you're gonna have people in standby. So basically the standby station is kind of where a train that is going to be ready to go and pick up some resources is going to wait for the resources to be available, for it to fill up, and before it goes and dispatches them. Right, so at the moment there is I've done a copper thing just to check that all the blueprints were working properly, but to showcase the blueprints themselves, let's just get into it. And so here we've got copper plates. What we're going to do is green chips, right? Because we love green chips. So to start with, you have the dispatcher smart station head. So basically it's what comes at the very top of the train. In my designs in general, I like to have a 2 locomotives head train, just for the speed of things. But really, if you want to have just one locomotive and the trains, the blueprints are completely modular, so you'll be able to add up one wagon that is going to transport the resources, or one more locomotive, or whatever. It's really up to you. So, like I said, I'm gonna have a second head. So just snap. All the blueprints supposed to just snap properly. If it doesn't snap, then you're maybe not in the right orientation, but it's just not right. Obviously, you don't have to have the tiles. The tiles are just a visual aid. Great, so we're going to have 2 locomotives here, so let's put 1 down and 2. We're going to just daisy chain these guys, because the way I've tried to think of it is, if you've got all these guys, so, well, a bit of spaghetti here. What am I doing? It's too early in the morning. Great, so that was going to fit this one up, and we're going to do this here. Here we go. That should fill up the locomotives nicely. So now, let's say for copper plates we need a lot of resources at once here. But green chips, because the stack size is 200, you don't need as many wagons, I don't exactly know how you're supposed to pronounce that. You don't need to have as many wagons transporting the resources, right? Because you've got twice as much in much shorter dimension. So we're just gonna go for a 2-wagon train. So we're just gonna put the oh, so where's the loader head? Again, everything's supposed to snap. If it doesn't snap, something's wrong. So you snap that one. The head is basically here just to snap properly with either this section or the extended section for the locomotive. So everything has its place. It's very particular. It's not just done by mistake. And then we put the tail. So the tail is pretty much exactly the same thing as the middle extension, only it doesn't have another bit at the end to extend for the more. Great. So if we look at the logic for a second. So I'm using the train signals, all train signals after the locomotive to measure how many wagons is, how long the train station is in terms of how many wagons. Right, so I've got 2, which, so the only thing so far that are sort of hard-coded are the default, some of the default values that we've got. So for example here, the stack size, you'll have to change it to 200 because that's for the green chips, which is 200 per stack. If you decided to not have the iron chests here, but to use the steel chests, you can upgrade that. That's no problem. You just tell the boss to upgrade. Again, I've done these blueprints so you can have them very early in the game, and for them not to be so expensive. If you want to change, for example, the stack inserters into the fast inserters, the only difference really is going to be how long it takes for you to load the train, but it's going to be, you can use that blueprint very early in the game. These inserters here for the loader train station are not enabled into doing anything, so whatever the signal is, it's not going to do anything about it, but it does for the requester consumer station. Right, so at this point the station is empty. We want to say, so the way I've also approached it is that what I wanted to do is to broadcast on the network either how many wagons worth of a particular type of resources I've got available, or how many wagons is being demanded. So don't do the math based on the quantity that is demanded, I do the math based on how many wagons worth of that one resource do I need to have. So at the moment I'm not broadcasting anything on the network, so we're gonna do that. Let's connect this guy up out here and to the main network. So at the moment on the main network you can see 57, because that's how much this station has available of wagons, but there is no negative value, so therefore that means that there is nothing that is on demand, but we'll cover that in a second. So at this stage the station is empty. We're using steel chests now, so we do want to do the math based on the size of the steel chests. So this station in total can store up to 230,000 ish worth of green chips. Right, so let's fill this puppy up. Let's use some infinite chests. So everything also is balanced for loading and unloading. It's the exact same design, same principle. So for example here, if I put green chips, it's going to start loading it, but then it's going to stop because it's expecting for all of these all of these chests must have the same value before they try to insert anything else. So if you've got an uneven loading, because I don't know, you've got an inconsistent source of resources coming into the train, it's not gonna load it. If the station opens, that means that it's 100% sure it will be able to start to fully load one wagon. Right, so let's carry on and see. As soon as everybody has resources, then it carries on. Great, we're gonna give that a minute. I'm also gonna change these guys into stack inserters, because this is chips and we want to, don't really want to wait 200 years before the station is open. Great. So we're just gonna rename that station to dispatcher grain circuits, and you can name them the way you want. But at the moment the station is completely neutral, so it's not announcing anything, because you have, this is the last part of the puzzle, you have to announce, also, yeah, okay, let's go back to that in a second. You have to announce what it is you are providing. So until you do that, your station is not saying anything, so nothing is gonna come in either. Right, so you're broadcasting, then you can have 2 wagons worth now of grain chips. Now 3, now 4, and it's gonna carry on like that forever. If it's beneath 2, because again the length is 2, it's not the station is not gonna open. The train is gonna come and try. Also, obviously that's 2-sided train, and it's got 6 chests if you prefer designs with full chests and single-sided, for example. All I have to do is go back to the constant combinator here and change the rail number to the number of sides you're using and the inserter number by the number of chests or inserters, because usually they are a 1-to-1 match, that you have in your station. And this is where it's completely modular, and if you disconnect these things you'll have to do some rewiring, but it's completely up to you. You can just change these values, blueprint that, remove some chests, and blueprint that again if you want to have 4 in single side. Great, so moving on, at the moment our train station is loading up. It's got 7 wagons worth, so naturally we want to go to the carrier. So I'm just gonna copy paste this blueprint. No, actually I'm gonna put it down properly. So this is a carrier station. So again, same principle, we put a head to it. We're gonna daisy chain these guys. Okay, the way it's done, the way the logic is done, which we'll come to in a minute, is that you don't have to worry about which wires you're connecting. The train stations are already doing the filtering. So if you're using a carrier station, it's gonna only use, oh, obviously it's gonna be out of range for these guys. Yep. Okay. Finish that station, please. Yeah. So this is kind of the brain split thing where the maths are done to let know the standby and the carrier stations if resources being requested or if resources is available. So on this side, what's going to be onto the green pole, onto the green wire is what's available to the network, and what's going to be on the red wire is what's requested by the network. At the moment there's nothing requested, mostly because the station is not emptying anything into infinite chests, but we'll go back to that in a minute, just to demonstrate that when this is lower than the minimum, it's gonna close up, it's gonna open up again, and train's gonna start shoving stuff into it. Great, so at this point, so we've got the station here, and we are going to also, yep, nope, I haven't finished. So, I'm actually going to explain how to put down the blueprints for the carrier station. So, the extension, you snap it, and if you've got trains of various sizes in the system, this is where you do the things. The only restriction so far is you must then have, unfortunately, you must have trains that all have the same number of head locomotives in the system. That's one of the very few downsides of this, is that for now you have to, because all these stations are named with the same carrier name, the way it works is you have to discard the first 2 signals, which are wired, because if you put one here, it shouldn't count as one head. But yeah, because again, all of the stations are going to measure the length of all the trains that are inside them. The reason for that is, for example, if we had a 3 wagon trains here for the copper, and here it's a 4 length requester, obviously the 3 wagons worth of resources is not going to be able to fill in the entire base, and therefore the thing is actually going to say, no, I mean, thanks very much mate, but I can't actually make use of you, and I'm going to have an unbalanced output, so no thank you, go away. So again, chuck, what have we got here? So at this point, we're going to tell this guy to go to the dispatcher green circuits, wait for full cargo, then you should go to the carrier and wait for the circuit condition. So it's gonna need to be requesting something. You should also only stay here if you've got a full cargo. and you must have the amount of circuit stays being demanded should be bigger than your size, because otherwise it's asking you to move but for nothing. Or, because I always put an or in case, or you're just being inactive and you've got an empty cargo. Right, so let's go to this location. Oh shit, it doesn't have any wagons yet. That's fine, because none of these things are going to be true. Well, yes it is, because you are empty technically. So we're gonna go back to this thing and then we're gonna wait for it being full, so we're just gonna wait for a second for this guy to come up. Yeah. And here we go. Okay. Gonna do it this way. Stop where you are. Thank you. 1, 2. Brilliant. And go back here. And so it's empty. This is not going to do anything, therefore it should move back to the thing. I'm going to catch this guy again and tell it to go to add a station to the standby. Go to the standby please, and conditions are going to be pretty much exactly the same. So, well, this time obviously it's going to be on a different signal, so it has to be bigger than 1. Going to wait for an empty cargo, and you should have. There should be more available than the length of you. And then, so, or you've got an empty cargo, or you've got a full cargo, and you are doing nothing. Right. So it's gonna be filled up, 16 grand, 16,000 chips into it. But at the moment, there is no requester on the network. So the requester works exactly in the modular way, exactly in the same way as the source base is. So I'm gonna put it down over here. So the requester smart station, the head, put it in the right sense. Chuck, here we go. And then it's 2 length, so but with 1 extra wagon locomotive. So snap this in here, and then. We need to have another head section, because again, there is one that needs to snap to either the head or the extension. And then, interesting, do it again. Anyway, sorry, and then we're gonna put 1 more of these things. So actually, I'm gonna demonstrate that. So this station now, right, it's going to be wired. Oh, also on none of the blueprints here, I'm only using the medium poles to provide power, not to transport information at all, so you can never fuck it up in case you want to connect the network. More importantly, I'll never fuck it up, because then I would, because I'm a terrible human. Right, so displays something, but it's not telling what it wants, and what it wants is going to be green chips. So we're going to say it's a requester of green circuits. Yep. But it's slow, so it requests. So this is 1 station, so basically with these chests, blah blah blah, do the same maths again. The only thing to change here is going to be 200. It's 2-sided. Basically what it wants at this point is what it can store. It wants to have as much as possible in the chest, and the chest here is to be full before it can close the station. So at this point it does the maths and says I can have about 9 wagons worth of resources stored in these chests, right? Because the maximum is going to be 76,000 with the size, etc, etc. So if you do the maths, then it's 9 wagons worth. So we're just going to add the extension. Actually I should have done that. That's one blueprint I can do. So we're going to discard this bit at the end because we don't need it. I should have done that. For the another as well. But here's the tail. So the tail of the station again is going to be here in case, and we're going to forcibly make this guy go in there. In case the train that comes in is... Oh, damn it. Should have... Oh, remove all of that, please. I'm gonna need to demonstrate that. So, let's say you did a mistake. You forgot that your train can only have, like, up to... your trains is 2... Oh, yeah, it's gonna go away. But this station is only 1, right? So, first off, this guy is not gonna go in. But also, if you put a tail in here... Oh, no, sorry, it's the other way around. Yeah, never mind. We'll be clear one day. Once I'm doing tutorials. Yeah, okay, let's just add an extra, okay, for the sake of the argument. All the bots are gonna do the work for us anyway, so. And let's put a tail. So the tail... I don't need this guy. Inventory too full. Typical. Alright, so now this is a 3 wagon station and it's asking for 28, blah 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 blah. If we put a tail to it right now and we take this train and we tell the train to go to the station, all the boots. We're gonna go in ourselves. Okay, you now have to go to a requester grain circuits and have an MC car code. Yep. Standby. So the standby comes before the dispatcher, then the carrier, then the requester. So let's send this guy to this. Right. It's going to tell you, it's going to have a little alarm saying the train is too short to fill the station up. Therefore I don't want to do anything. This guy, if you put an inactivity signal, right, it's going to be like, oh, well I'm actually not done anything. So I haven't found yet a very smart thing that allows me to know when I'm going to send the train into the stations, that the station is actually the size that it needs to be. But for now, it's not so bad. So I'm just gonna remove all of this bit to make it a 2-length station. Then I'm gonna put the tail again. You don't really have to put the tail again if you don't want to, but I just like to follow the blueprints. And then put back this thing. Yeah, I had to remove the... Yeah, here we go. We've got enough. The train is just the length of the station, therefore it's accepted, therefore these stack inserters are doing some job. Okay, so here we go. Right, now it's going to unload. The train is going to carry on. So let's have a look on the network to see what's going on. So that station obviously now is broadcasting a once chip. So if we look at the medium pole, if you always look at the medium pole of that brain split thing, you're going to be able to see the demand versus the available, the supply. So at the moment, we've got a station that can supply 11 wagons worth of chips, and we've got a station that has for 17 wagons worth of chips. So we've got a higher demand that we've got supply. So this is where you'd start multiplying these guys, having more than one of these dispatcher to be able to fulfill the demand. Either more than one or just more trains, more carriers. If you've got enough throughput, as in you've got enough enough chips that come in, that you produce enough chips to supply the demand, then you just need more carriers. And I'm gonna just do that. If I put one train and just another one, copy paste, and put it into automatic. Oh. Where is it going? Go away, because you're not ready for the fun of that. Anywho, it's not too much of a problem. Again, these guys are only going to unload if they can. So, with margin of error, well, there's a margin of error because of the maths. It's, if you want the decimals after the comma is a bit higher, so maybe it's not going to be exactly the same number. But um, basically these guys stopped because this guy here has now too much, and so the conditions on the network are not true anymore. Therefore, this guy stops. Then this guy carries on again, and everybody can go. So basically, if you have a station and you haven't been able to supply anything, then the chests are just getting empty. All the chests with margin of error are gonna get empty all at the same time. So whatever design you've got, and this is why I haven't put anything on the output of this, right? Because everybody has its own version of what an unloader track should look like. So we've got people who do something like that, and we've got people. So typically in this situation, the two outer things are going to be empty, but the two in the middle are going to be full, and then you end up with unbalanced stuff. Some other people do something like something like that, right? And really, it's up to you. It's up to what you prefer to do. Like I said, it's really up to you what it is you really want to do, and what works for you. But what's going to happen is this is not going to work. So if I duplicate this, for example, boom, put one here, here. Just going to put these guys manually. These, by the way, are fast loaders, express loaders. So it's basically, instead of having inserters, it does the job for you, which is much nicer. So like you can see in this case, right, the middle ones are going to have the same number as the outer ones, and everybody is completely in sync. So whatever the way you unload, whatever the design of your unloader, really, it's all just gonna work. Great. So basically that's how it works. So where are our trains now? Oh. It's not completely empty. Damn, I need to do an extra condition here then. Where was all cargo? Yeah, I'm just gonna put an or to that. Again, you can add much more logic than that to the trains and everything. I find it's funny because I kind of find the logic you can put in the trains with one top or multiple ors and ends beneath it much more powerful than some of the combination you can do in here, because it's only one to another thing that you compare. So let's speed things up a bit and see if we can get the station to be full. Let's look at the numbers. Yeah, it's going up, but it's going to take a while to fill completely up. Let's split things more. Here we go, blue. So the station is full, so it's not going to send any request anymore to the network. So if we look on here, on the grid, we've got stuff that is available, but nothing is demanded. So yeah, that's pretty much how it works. The reason for the carrier stop and the standby is that the standby you're gonna put right before the dispatchers. Okay, again, it's kind of your fleet of carriers that's gonna be here. It's gonna wait just for the go signal to say, I've got trains that have enough resources, I've got stations that have enough resources for you to load up. And then this carrier sort of stacker, which you can really compact, is all the stuff that is going to already have a load worth of resources ready to go. So for the geeks amongst us that do with networking and web servers and that sort of stuff, you can kind of see that as this is the web server, this is the original source, and this is the content delivery network. So you can put these things much closer to where you need them, and you could very much even, let's say you have a red circuit factory and you want to have green circuits trains that are going to stack up. You can do a stacker and just rename stuff, rename these carrier to carrier green, and these guys are going to go to the carrier green circuit, and they're all going to stack up and just going to wait for things to be demanded as soon as there's a demand. But obviously that means you have to also think about what would be the maximum number of trains I want to have stuck in there before that station, because otherwise it's going to be stuck, and if somewhere else needs green circuits, these guys may not be going if there is no path to it. So you should always also think of an exit plan. So if this guy is not asking for anything, but somewhere else it's asking for green circuits, then these guys have an escape route to go elsewhere. Right, that's pretty much it. Like I said, everything's modular. The sort of things I didn't like in the vanilla train network is, you have to define the size of all the things. I prefer to do the maps. I mean, it takes a bit more space, for sure, but when you look at the space of a dual-sided, which is pretty much all blueprints you can find on Factorio prints, everybody uses double side, so I was like, okay, I'm just going to use double side, compact it as much as I can, put all the logic in there, make it so you can tile that to 6, 8, whatever number of wagons you want, and that's it. Also, the design here is for one-way only trains, but you could make that work for more than one-way only train. You just need to re-implement the tail thing at the back of these stations exactly like I've done here, because obviously, again, if you put a locomotive at the back to go the other way around on the network, you need to discard these guys and not count them for the count of the number of resources wagons you've got. I've not done yet something for oils, but soon, and it pretty much is exactly the same thing. Instead of inserters, you'd have bombs and tanks, and all you want is the exact same logic. And basically I'll be putting here something like this guy and his 24,000, and that's it. And then you do that, it's going to be exactly the same maths, you just change that over here and it's all just going to work. Cool, well that's it really. Please feel free to give any sort of feedback or ideas, or if you have got any complaints, or if you feel like it's really bad or really not great or whatever. That's your opinion, you're entitled to it. Oh yeah, before we go, one thing I was going to forget about. This is the first splitter I've put into the system. It's really important that only one, if you put more than one of these guys into the network, and you probably will, it's important that only one of them is connected to the network, because it's also outputting the dot signal. So very quickly, because I've seen a lot of videos of people trying to explain the vanilla train network and the numbers that are showing up when something is requesting. So let's speed things up. So this one is requesting something. Okay, it's going down. So basically the way it works is for the demand I'm multiplying by 1 the number of wagons that I need, so it's a negative value, blah blah blah. But the bit shifting, basically what it does, it's going to add in front of the number as many zeros as the number that is shown here in binary. So this is why we go from 14 to 917,000. It's because you take 14 in binary, which is it's not 16, so it's almost all ones, but 2 zeros are going to be left out basically. It's going to add a lot of zeros in front of it, and at the end of that, this is how you get the number. So basically what it does, what that allows us to have, is to have a positive value on the network and a massive negative value on the network, and basically this does the maths to reverse it. Sorry. So this is going to be the thing that removes the zeros and gives us the big number into the small number. So now we only need 13 wagons worth, because we've just loaded now 12. And on the other side we do the maths in the reverse way to get the positive value. But if 2 of these guys were to broadcast to the entire network, the 16 that is set by default would become 32. And basically in programming languages you've got values that can be no bigger than an int, which you've got signed int and then signed int. I'll put a link for the curious guys of you that want to figure that out. But basically there's a maximum value of 2 billion whatever, 2 power 42 or 2 power 16 or no, 2 power 42. Yeah. Anyway, so if you've got a too big a number across the entire network, it's not going to work. And again, the reason why I've done that is only for the sake of not hard-coding something. I absolutely hate hard-coding. Everything has to be a variable in my world, otherwise I just go nuts. Some stuff have to be hard-coded. Like this is sort of hard-coded. This is hard-coded, but because it's static variables, it doesn't need to change. It never does change. And if there's a new, and also if there was a 018 coming out tomorrow, and the values for these chests, the amount of stacks per chest that we're going to change, then I can just change that in the blueprints, and I'm good to go. Anyway, so that's it. Thank you very much for watching. If you've got any questions, please feel free to ask on Reddit or anywhere else really. And thanks very much for watching. Bye bye.